In this section, we are going to talk about the quadratic function. Indeed, you see quadratic function everywhere. For instance, if you are the one like to play basketball, you do a ball, right? The path of the ball indeed can be described by a quadratic function. So we call that projectile. Okay, let's talk about this function and go back to the equation. We have seen function look like this, a parabola. This is called a parabola open upward. This is x and y axis, and let's see another parabola that's open downward. Okay, and you see these two functions graph. You can see that this one have the lowest point, this one have the highest point, and the turning point we call that is vertex. So in this case, the vertex is the minimum, and this one is vertex, but that one is maximum. Alright. So all the quadratic functions graph, it look like a parabola. And if you draw a vertical line passing the vertex, basically you can fold these two graphs overlap to each other, so they're symmetric. So this blue line, we call that is the axis of symmetry. So this one is open upward. So this one we call that parabola. Open upward. And this one is open downward. Quadratic functions is a polynomial function with degree of 2. So what it means in here is that all these graph can be represented by these functions is ax squared plus bx plus c. Okay. In here you can see that a, b, c are any real number. And which is required a cannot be 0, because if a is 0, that is just a linear function. And so this is called quadratic functions. With this case, if we see that open upward, the a in this case is greater than 0, and this one a is less than 0. When a has positive, the graph is open upward, and then when the graph is open downward, a is negative. Okay, so we talk. You can see that the vertex is the turning point, the symmetric axis, and then you can see the symmetric axis is passing through the vertex. If we know the vertex coordinate, then we should be able to find the equations of the symmetric axis, because it's a vertical line, so it's x equal to vertex x. Let's see, for the quadratic function, usually we have two kinds of equation. One is we call that is standard form. In the standard form, the functions is written as f of x is equal to ax minus h squared plus k. Alright, think about the parent function. We talk about the parent functions in chapter 1. Quadratic functions, parent function x squared, it looks like this. Okay, and if you have the a multiplied by that, it's just like open wider or closing thinner. So let's call this as f of x equal to ax squared. So if you do transformation, if the vertex somehow translated to somewhere, let's say right here, so which means go to the h as your x and k as your y for this point, so you probably go up to here. Okay. So use the transformation we learned. Indeed, the equation can be written to a times x minus h squared plus k. So in other words, from this equation, the standard form, we can easily to read the vertex is located at HK, that point. And since the symmetric axis is passing through the vertex is a vertical line, therefore the axis equation is x equal to h. So no matter it's open upward or open downward, the graph should be represent the same idea, the vertex, what I meant. So if you open downward, from the standard form, you can directly know the vertex is located at HK, and the symmetric axis on the x equal to h, that vertical line. Okay, so that is we can connect it with the transformation we learned in the last sections. So this is called standard form. Again, this is a greater than 0, you have open upward, and a less than 0, you have the graph is open downward. Let's see. Let's practice some graphing for that, and not using transformation, but using the vertexes. Okay, so let's see. We are going to graph the quadratic function f of x is equal to -2 x minus 3 squared plus 8. Okay. We are going to have several key things in our graph, a little bit different from the transformation we learned in chapter 1. So first one, we are going to see if it's open upward or downward. So in this case, A is -2, then we know the graph is open downward because the leading coefficient is less than 0. So in my mind, I know the parabola is open like this. So I still need to determine the locations and how wide it open. Okay, the second one, I'm going to find the vertex. And the vertex, in this case, since it's in the standard form, I can read the vertex directly from the equations. Get easy to see the vertex located at 3, 8. Well, if you have the vertex, then the symmetry axis, which is the passing the vertex one, is a vertical line, so I can identify that as well. So the axis of symmetry is x equals 3, right? Alright, so let me see what I can get on the side. I might still need to have some assistance point for me to determine the graph. Okay, let's see. So I have vertex located at 3, 8. Let me use this as a 4. This will be 8. So that's vertex. And I know that the symmetric axis will be passing the vertex. And that's it, that's all. And also the information we know that open downward. But the thing is, I don't know is open this big or this big or this big, right? So we need some points. Usually those points we like to use are the intercepts. Okay, for instance, we are going to find y-intercept and x-intercept. Okay, y-intercept. It doesn't have to be in this order, right? So remember how to find y-intercept. Y-axis is order x equal to 0. So basically you left x equals 0, and so the corresponding y. So if x is equal to 0, then y is equal to -2 times 0 minus 3 squared plus 8. And that will be -18 squared. Sorry, I got the answer. I don't know. I'm thinking. I thought the answer already. 3 squared is 9. 9 times -2, -18. That's what I meant. Plus 10. Plus 8. That is -10. Okay, so you have -10 down here. So that's the y-intercept. you can use the y-intercept and also symmetric idea to graph another point, which is on the right hand side of the symmetric axis 3 union waveform here. So that's a point right here. And I would like to have another 2 points, which is the x-intercept. I know that I have x-intercept since the graphs are open downward. So let's find the x-intercept. X-intercept, we are going to let y equals 0, right? So which is we get -2 x minus 3 squared plus a equals 0. In order to solve for x, I'll undo the operation, go reverse of the order operation, addition last. Now I'm going to undo the addition first. So subtract a, so what I get is -2 times x minus 3 squared equals -a. Then I need to divide both sides by -4. That will give me x minus 3 squared equals to 4. Take square root. When you take square root, don't forget to apply the square root principles, positive or negative square root 4. So which means you have two situations. One is x minus 3 is equal to square root of 4, which is x minus 3 equals 2. That gives us x equal to 5. Or x minus 3 equals to negative square root 4. That's positive negative meant. So the x minus 3 that is equal to -2, which is give us x equal to 1. So we have two x-intercepts in here. Alright, so one is located at 5 and one is located at 1. So if I connect those points, having the graph shape in my mind is like proper. So that is the proper we get. Okay, we grab the proper based on the information of the vertex, y-intercept, x-intercept, and also the symmetry. Let's take a look of another one. We are still seeing the equations in the standard form. Alright, so that equation will be, let me call that g of x is equal to x plus 2 squared minus 1. Okay, so similar idea. Let's see what's the leading coefficient. Leading coefficient is the 1 multiplied by the square. In this case, you have an invisible 1 right here. So the a is equal to 1, which is greater than 0. To give me the idea is open upward. And let's see what else we can find. Well, we can see the vertex right away from the equation since it's a standard form. So the vertex is hk, right? Hk, remember this is minus h plus 2 is some idea is minus -2. Therefore, the vertex x coordinate is -2 and y coordinate is -1. And the axis of symmetries is a vertical line. Vertical line equations is x equal to constant. The constant in this case is -2. Similar idea. Let's see what I can get in here. So that's my x, y axis coordinate, and the vertex located at -2, -1. So right here, and the symmetric axis is passing the vertical line. Okay. By the way, oops, that does not look like vertical line. That's assuming that's a vertical line. By the way, when you grab the functions in your online homework, make sure you including the symmetric axis. Otherwise, the system will count it incorrect. Alright, so the vertex will located here. Symmetry open upwards. I still have does not have enough information to plot the shape. So let's see the y-intercept. Hopefully we can get that to help us. Y-intercept is letting x equal to 0. If x equals 0, put that into the equation, then y will be equals to 0 plus 2 squared, which is 4 minus 1, that equals 3. So y-intercept is located at 3, right here. And also you can use the symmetric idea, which means 2 units on the left hand side of the symmetric axis. That should be having a point which is height is 3 as well. And also let's see if we will have x-intercept or not. The x-intercept, we are going to let y equals 0 and so for x. So if y equals 0, let's see, we have x plus 2 squared minus 1 equals 0, which means x plus 2 squared is equal to 1, and take the square root from both sides. X plus 2 squared is equal to positive negative square root of 1, so x plus 2 is equal to 1, or x plus 2 is equal to negative 1. From here, that I'm going to subtract 2 from both sides. X is equal to negative 1, or x is equal to negative 3. So negative 1, negative 3, I have the x-intercepts right here. I'm going to graph this function, open outward. Alright, so that is the parabola we are looking for. Let's see one more example. This time I'm just going to change minus 1 to plus 1 to see what happened to the function. We are going to grab h of x is equal to x plus 2 squared plus 1. Okay. Very similar to last example. Okay, if you think about the last example, what we did is, let's see, the leading coefficient is a greater than 0 because it's 1, so it's open upward. That does not change. Okay, let's take a look at the vertex, if the vertex change or not. Yep, the x still the same, which is negative 2, but the y change is 1. And the axis of symmetry will be x equal to negative 2. It's the same axis, the axis symmetry of the last example. Let's take a look at the y-intercept to see if it changed or not. Okay, y-intercept, you let x equals 0 and find the corresponding y. If x equals 0, y will be 0 plus 2 squared plus 1. That's 2 squared, 4 plus 1, that is 5. Okay, so the y-intercept is different. And let's take a look at the x-intercept. What happened to the x-intercept? In x-intercept, we say let y equals 0, so the equation will become x plus 2 squared plus 1 equals 0. X plus 2 squared is equal to negative 1. Right? Can we move on that? Okay, wait a minute. Is square equal negative 1? We know that there's no real solution. We have complex solution from last class, but there's no real solution. What does that mean? That means no x-intercept. Okay, if we use the graph to take a look, it makes sense. Let's see what the graph is. If x here, y is right here, and the vertex located at negative 2, positive 1. So that will be right here. And the symmetric axis is right here, right, passing the vertex. And the y-intercept we found that is 2, 3, 4, 5. Oops, that's planning. So that is the y-intercept. And the symmetry, we're applying that on the left hand side 2 unit away, that should be a point right here, the same level as well. And you can see the graph is open outward. They definitely cannot intercept x-axis. If you use the graph, you already can conclude there's no x-intercept without calculating, right? Okay, so let's take the graph forward. Try my best to make that as a symmetry. Okay, so that is the standard form. Again, the standard form of the quadratic equation, you can read the vertex directly for the equations. Okay, you can, it's very convenient to find the symmetry of x's, right? So when you find the y-intercept, you just let the x equal to 0, substitute into the equations. So for the y, if you're looking for x-intercept, you let the y equal 0 and find the corresponding x. Sometimes you might have 2 x's, sometimes you might have none. Alright, so the second one, let's see. Also, we have the quadratic function can be written as a general form. The general form looks like f of x is equal to ax squared plus bx plus c. So that A is leading coefficients for that. Okay, so with that, you can see the disadvantage of this one, which is I cannot read the vertex from this one, right? So how can we find the vertex? So in this lesson, I'm not going to do the completing square. I will put that in other videos. If you are interested in that, you can take a look how this come from. But right here, I'm just going to give you the fact. When you look for the vertex x coordinate is negative b over 2a, and the y coordinate, basically you just put the x equal to negative b 2a into the equation to evaluate that. So which means that the axis of symmetries can be found by using x equal to negative b over 2a. Alright. The good news for this formula is we learn the quadratic formulas, right? If you look for the x-intercept, you're setting y equals 0. Basically, you're setting ax squared plus bx minus c equals 0. With that quadratic formula, your x can be found by using negative b plus or minus square root of b squared minus 4ac divided by 2a to find the x-intercept. Right, let's take a look at an example. Right, if you only get the formulas without seeing numbers, sometimes it's hard to understand how you apply those numbers. So we are going to graph the functions f of x is equal to negative x squared minus 2x plus 1. And let's see, what is a in here? Is the coefficient of x squared, which is negative 1. B is negative 2. C is 1. Okay. A is negative 1, then we know that a is less than 0, and the graph will be opened downward. So what's the vertex then? Okay. So the vertex, I cannot read it from the equation directly, but what I can do is applying this formula. Okay, so with the vertex x is equal to negative b over 2a. Well, we know b is negative 2, a is negative 1, negative still got negative, so that is negative 1. If the x coordinate is negative 1, then the y coordinate, which is what we are talking about, negative b over 2a, indeed you are going to evaluate f of negative 1, which is give us negative 1 squared minus 2 times negative 1 plus 1. Negative 1 squared is positive 1, still negative, so that is equal to negative 1 plus 2 plus 1, that gives us 2. Therefore, your vertex is located at negative 1, 2. Let me write in here, negative 1, 2. Okay. So with that information, I can write down my axis of symmetry. Which is x equals negative 1. Similarly, I would like to have y-intercept and x-intercept to help me graph the functions. Y-intercept is letting the x equals 0. If x equals 0, then y is equal to negative 0 squared minus 2 times 0 plus 1. See, for the general form, the nice thing is the c, this number indeed just your y-intercept. You don't need to calculate that one. So that's 1. Okay, and your x-intercept, we are going to let y equals 0, which is negative x squared minus 2x plus 1 equals 0. To solve this one, if you feel comfortable with factoring, you can go ahead to try to use the factoring trinomials technique, or you can just go straight to use the quadratic equation, the quadratic formula, x equal to negative b plus or minus square root of b squared minus 4ac, okay, square root of them, and divided by 2. So that will give us 2 plus or minus 4 minus minus, that's plus. 4 plus 4 is the square root of 8. Square root of 8 can be simplified as 2 square root of 2. So with that, you can continue simplify this, and the plus minus, you just separate them. Okay, so that will be, so you can see x is either equal to 2 plus square root of 8 is 2 square root 2 over 2. That's the same as 1 plus square root 2, cancel out the common factor 2, or x is equal to 2 minus square root 2 square root 2 over 2 is equals to 1 minus square root 2. Square root 2 is approximately 1.4, so this is approximately 2.4, and this one is approximately equals. Did I copy the problems incorrect? Yeah, I think I made a little bit mistake. 2 minus negative 1 in here. So that is negative of that whole thing. So negative 2.4, and this one will be negative 1 plus square root of 2. Sorry for the mess. Hopefully you can see that. So this one is approximately negative 2.4, and this one is approximately 0.4. We can use those information to graph. Okay, I'm just going to put the graph up here so you can see the corresponding relations. So that's x, y. Okay, so vertex located at negative 1, 2. So that's the vertex. And the symmetric axis passing through negative 1. So it will be right here. And the y-intercept located at 1. And you can use the symmetric idea. You know that's another point right here. And the x-intercept, you see that one is approximately 2.4. 2 is right here. 2.4 more or less right here. The other one is located at 0.4, a little bit less than half. So that is your graph. Okay. Now I'm going to just go ahead to use this graph to talk about the domain. The domain is from the most left point to the most right point, and you can see the quadratic functions have the parabola shape. You can go to left infinity, go to right infinity. Therefore, the domain in this function is negative infinity to positive infinity. And the range is what's the lowest point to what's the highest point. So the highest point here is the vertex we talk about, that's the maximum, right? So the range in this case is from negative infinity to up to the 2, that point, but also including the 2, because that's a solid point right there. So that is the domain and range of quadratic function. So you can see in general the quadratic function's domain is all the real numbers, and the range is if you have a greater than 0, like this case, the range is starting from your vertex and go all the way to infinity. But if you have a less than 0, then your range is from negative infinity go up to the vertex for that. Okay, so that is in the quadratic functions. And I did mention the maximum or minimum. So let me just grab the two proper very quickly. This is a greater than 0, and this is a less than 0. Right. So you can see that this turning point vertex in here, this one is, this graph have minimum, and this graph have maximum. So that if you put that into the xy coordinate, we can tell this minimum is occurring at this point h, and the minimum value is k. It's the vertex value, right? So if I put this one in the xy coordinate as well, so the maximum is occurs at x equal to h, and the maximum value is the y equals to k. Okay, so it's just the language used is a little bit different. The concept behind that is the same. But looking for the minimum or maximum is the same concept. Looking for the vertex and where the vertex is. Okay, so again we say that minimum occurs at x equal to h or negative b over 2a, depend on what form you're looking at. And the minimum value is k, or the negative b over 2a, put that into the function to evaluate. Similar idea for this one. Maximum also occurs at the vertex. Remember, the vertex is a, is at the x is equal to h or negative b over 2a, and the maximum value is k equals to f of negative b over 2a. Okay, either one will be fine. Let's practice our problems. We are going to determine whether the function has a minimum value or maximum. And then find them. Okay, so the function, let's practice one in the general form instead of vertex form, because the vertex form is easy to take a look. F of x is equal to negative 0.01 x squared plus 1.18 x plus 2. Okay. Indeed, this is a function describing the football prototypes. And you can see that in here, your a is equal to negative 0.01, which is less than 0. You know the graph is open downward, which is the vertex is representing the maximum. So f has a maximum value. Let's find what the maximum value is. Okay. So the whole problem will be translated into looking what's the vertex. So finding for where it occurred, that your x is equal to negative b over 2a. B from the graph we can read is 1.18 over negative -0.01, that is the a times 2. Don't forget that part. So negative positive, that's divided by 2, so that's 59. So that is the x. Okay, how about there is where it occurred? So that means the maximum occurs at x equal to 59. Now our next question is, what is the maximum value? Okay, so the maximum value, we'll put that x equal to 59 into the equation, -0.01 times 59 squared plus 1.18 times 59 plus 2. Okay, so let's put those information into your calculator, and that is approximately equals to 36.81, which means the maximum value is 36.81. Right. So that is how we find the maximum and minimum by using the vertex information. And I hope that that can help you to understand a little bit of the quadratic functions. Of course, we are going to learn a little bit more in the future courses. Let me just go back to revisit some of the information as a conclusions. Quadratic functions, if you have the standard form, you f of x is equal to a x minus h squared plus k. If the general form, f of x is equal to a x squared plus bx plus c. Okay. So both of the equations, you can see we both use a, the leading coefficient equals a. Indeed, the a's information are the same. If the a is greater than 0, the parabola is going to open upward. If a is less than 0, then the parabola is open downward. They apply for both cases. And also we talk about the vertex in the standard form. The nice thing about the vertex is we can read it directly from here. But from the general form, we cannot read that, so we have to find it by using negative b over 2a and evaluate f of negative b over 2a. So that's the vertex. For the axis of symmetry, for the standard form, I can just let x equal to h, the same idea. And here, as long as I find the vertex, I should not have trouble to find the symmetric axis in here. Okay. So for the y-intercept, they both is going to let x equal to 0. Okay. Well, for this one, you just solve for that f of 0 equal to what the number, and this one indeed, this one is a little bit nice. If you like to memorize that, indeed it's always 0c, but this one you need to calculate that. For the x-intercept, remember the x-intercept are the real 0. If you solve the quadratic equation, the solution is not real number, then we can conclude there's no x-intercept. So for this one, the x-intercept, or this one, you can just let y equals 0. For this one, you just solve that by using the square root principle, but this one you can use the quadratic formula. Okay. So this is the key things we are looking at in the quadratic equations or quadratic functions. And later on in this chapter, we are going to take a look at the polynomial functions. The quadratic function is part of that, and you can see some of the characters in the polynomial function as well. So I will see you in next class. Thank you.